Three units of measurement in the metric system that are most commonly used. They are the milliliter, the liter, and the kiloliter. Just as the meter was a basic unit of linear metric measurement, so the liter is the basic metric unit of capacity. A liter holds a little more than a quart that we learned about in the standard system of measurement. In metric capacity, the milliliter is the smallest standard unit of measurement. To give you some idea of how small a milliliter is, 1 milliliter is about the equivalent of 20 drops of liquid from this eyedropper, or it would take 3 milliliters to fill our thimble with liquid. So, as you can see, a milliliter is a very small unit of capacity, and it takes 1,000 milliliters to equal 1 liter. Or it takes the capacity of 333 1/3 of these thimbles filled with liquid to equal 1 liter. The abbreviation for milliliter is small m, capital L. The milliliter written as a fractional part of a liter is 1/1000th because it is 1/1000th of a liter. And like this when written as a decimal 001. Now I'm going to take the contents of my favorite juice, Kick-A-Pal Joy Juice, from this 1 liter container and pour it into this quart container so that you can see that the contents of a 1 liter container is greater than that of the quart container. Okay, as I'm pouring, smells good, and I know it would taste so good. We're almost there. I believe we're just about full. And as you can see, I have a little bit left over in my 1 liter container. So, as you can see, the capacity of a liter is a little more than the capacity of a quart. The abbreviation for liter is capital L. To help you understand the largest unit of capacity in the metric system, the kiloliter, imagine 1,000 liters of my favorite drink, Kick-A-Pal Joy Juice, dumped into one huge vat. Can you imagine a container large enough to hold 1,000 liters of my Kick-A-Pal Joy Juice? Hello? Oh, hello, Meter. It's my brother, Meter. Meter, I'm kind of busy, right? What? A bathtub? Meter thinks a bathtub might be large enough to hold 1,000 liters of Kick-A-Pal Joy Juice. What do you think? Shall we try it? We filled up the tub right to the overflow and found we had many liters of juice left over. I had to tell Meter we needed another tub. So, we filled a second tub of equal size, and still we had juice left over. Finally, after filling a third tub, we used up all of the Kick-A-Pal Joy Juice. Wow! 1,000 liters! So, it takes 3 tubs of equal capacity filled to their overflow to equal 1,000 of these 1 liter containers, or 1 kiloliter. Wow, that's a lot of Kick-A-Pal Joy Juice. The abbreviation for kiloliter is small k, capital L. Based on what you just learned, can you think of a container that would be measured in kiloliters? This is the first thing I thought of too. A swimming pool, since it holds thousands of liters of water. It would be measured in kiloliters. Remember, the prefix kilo means 1,000 liters. So it would be only natural to measure it in kiloliters. Now, can you think of another container that might be measured in kiloliters? A fuel tanker, right. Because of the large capacity of fuel it transports, its contents could most easily be measured in kiloliters. Now here's a unit of capacity we all recognize, the 2 liter container. Almost every beverage and soft drink in the world comes in 2 liter containers, including my favorite, kick-a-pound joy juice. Now here's a real-life situation where the container used allows you to calculate the amount of liquid in either metric or customary units. From the time they're born until they're eating on their own, babies are often fed from bottles and jars. These bottles and jars often indicate capacity levels in both customary and metric measurement on their sides. An active, healthy baby, such as Brandon, gets hungry a lot, but his food has to be measured out in carefully measured amounts according to age, height, and body weight. So imagine what kind of challenge that must be for Brandon's mom and dad, who have to measure out the right amount of food for 4 babies at each feeding instead of just 1. That's right. Brandon is one of 4 babies called quadruplets because they were all born to the same mother at the same time. Now, to make it more of a challenge, each baby has his or her own food requirements. All the more reason for our carefully measuring out precise amounts of food for each of them. Mom and Dad have to do that every day, several times a day, until the babies are old enough to feed themselves. Now, how would you like that responsibility? Now that we've learned to measure capacity using milliliters, liters, and kiloliters, and a couple of variations in between, now let's look at some other items, and you choose the most appropriate unit of capacity to measure each. A pond would best be measured in kiloliters. A can of juice or soda would best be measured using milliliters. In fact, a can of soda holds 355 milliliters. A bottle of window washing liquid would best be measured using liters. Now, an expensive bottle of perfume would best be measured using milliliters. A large can of paint would best be measured using liters. A tanker truck with a full supply of gasoline would best be measured using kiloliters. And a small bottle of syrup would best be measured using, that's right, milliliters. How did you do? Great, I hope. As we learned throughout this series, when changing from a smaller unit to a larger unit, we divide. For instance, with units of capacity, to find the number of liters in a container, when we know the number of milliliters, we divide by 1,000. But when changing from a larger unit to a smaller, we multiply. In this case, to find the number of milliliters in a container, when we know the number of liters in it, we multiply by 1,000. Let me show you what I mean. Let's say that I have 2,500 milliliters of liquid. To change this to liters, I simply divide by 1,000, which is very easy to do. All I have to do is move the decimal point 3 places to the left. Now, you're probably saying, but there is no decimal point. Actually, there is. In any number, if the decimal is not shown, it is understood that it comes at the end of the number. For instance, there is a decimal right there. So to move it 3 places to the left, I simply move it 1, 2, 3 places, putting it between the 2 and the 5. Therefore, my answer is 2 5/10 liters. Since this may be the first time that many of you have done this type of problem, let's do another one like it to make sure that you really understand. And this time, let's use a larger number. Let's try 48,000 milliliters. Now remember, to go from a smaller unit to a larger, we need to divide, and this time by 1,000. Our decimal point is located right here. Remember, if it's not shown, it's always at the end. And we will move it 3 places, 1, 2, 3, meaning that 48,000 milliliters is the equivalent of 48 liters. Now that you've changed from a smaller unit to a larger unit, let's do just the opposite. This time, let's change from liters to milliliters. For instance, let's say that we have 12 6/10 liters. To change this to milliliters, a smaller unit, I will multiply by 1,000. And to do that, it is going to be necessary to move the decimal point 3 places to the right. Now, when you look at this problem, you're saying, well, I can only move it 1 place. So what is necessary to do is to add zeros. Now I can move it to 2nd place, and then 1 more. And as you can see, the 12.6 or 12 and 6/10 liters becomes 12,600 milliliters when changing from a larger unit to a smaller. Now, let's do one more problem like this to make sure that you really understand. Again, we're going from a larger unit, liters, to a smaller unit, milliliters. So this time, let's try, let's say, 8 liters. Now again, to change from liters to milliliters, we need to move the decimal 3 places to the right. Now, where's the decimal? That's right, it's after the 8. It's understood it's there, even though you don't see it. So, it's going to be necessary to add 3 zeros because I have no place to move it at this time. So I will add 1, 2, 3 zeros. Now I can move this decimal 1, 2, 3 places, which means that 8 liters is equivalent to 8,000 milliliters. Now I'm going to put you to work, but before I do so, let me review one more time. If we're changing from liters, a larger unit, to milliliters, a smaller unit, it's necessary to move the decimal 3 places to the right. But the opposite is true when going from milliliters to liters. Then we move the decimal 3 places to the left. Here's your first problem. To find how many liters are in 9,000 milliliters, do we move the decimal 3 places, A, to the right, or B, to the left? If you said B, you are correct. By moving the decimal point 3 places to the left, we've divided by 1,000 and found that 9,000 milliliters equals 9 liters. Let's try one more. 25 hundredths of a liter equals how many milliliters? To find the answer, do we move the decimal point 3 places, A, to the right, or B, to the left? If you said A, to the right, you are correct. Once again, we're going from a larger to a smaller unit, so we multiply, and the decimal moves 3 places to the right. I hope you enjoyed answering these questions. On our next program, we'll study mass, which is something like weight, but with an attitude. I'll explain then. Till then, this is Miles McLeader. Until next time, bye.